Hello, people, ladies and gentlemen. I'm Tin Marković. I'm a engineer at Kiwi.com, and I'm going to talk about connecting hundreds today. What do I mean by connecting hundreds? I mean the abstract hundreds, the hundreds of our passengers, the hundreds of airlines we connect, hundreds of city we merge together, destinations, traveling, bookings, all we do. All we do at Kiwi.com. I'm going to talk about how KiwiCom works, what are some of our processes. I will mention things my colleagues have already gone through, so I'll speed through those parts. You don't have to worry. I'll explain who we are, why are we here, how does our development work, why do we use Kiwi, why do we use Python, what problems we have, what challenges we have, what assets do we use to pass these challenges, and how our daily work goes. I'll mention a couple of incidents, funny stories, and some tips and tricks we've got through Python. First things first, who am I? I'm a team leader at Kiwi.com. I work under Stanley in the booking tribe. I lead a team of 5 engineers. We work on booking and manage my booking, specifically the manage my booking part, where you get to edit your stuff before you depart. I like software architecture. I like solving problems. I like working with complex solutions that need to be made simple. I enjoy programming, really. What have I worked on before Kiwi? I have worked as a developer on bigger platforms. Before this, my biggest project was Open edX. Some of you might have heard of it. It's a learning platform used by many universities in the world. I cooperated with Texas University, helping them implement it, helping them integrate, and some other big names that are protected by NDAs. Where do I fit in the Kiwi picture? I've joined the company almost 2 years ago. I worked as a software dev and now a team lead from recently. And I worked mostly on making the old code, the code of Kiwis yesterday, working Kiwis tomorrow. We are focused on simply making travel better. We want to streamline travel. We want to make everybody who wants to come from point A to point B do so effortlessly, without any problems, without any complications, without having to worry how he's going to combine his flights, how he's going to find where and how to go, and generally to make the whole trip seamless. We use Python mainly because it's quick, it's fast, it's a super prototyping language when you need it to be. It's very flexible and very agile, mobile. I hate buzzwords. We had startup beginnings. We are still culturally a startup. We work on adaptability. We work by scaling quickly. We work by being very, very mobile, very agile, very fluent in our process. We don't do long meetings that require hundreds of participants to figure out a solution. We try, we fail, we repeat, and learn from it. Basically, we try to emulate the Python principle of EAFF. It's easier to ask for forgiveness than for permission. Our CEO vouches for every of the engineers that if they think that is going to be better for the company, can try anything. They will not be held responsible if they had a bad idea that just didn't go through, as long as it was made with good spirit, with good confidence. We encounter many problems in our day-to-day work. We have to contend with enormous scale. We have to serve hundreds of thousands of people every day. As my colleague said, we move small cities every day from one part of the globe to the other. We make dozens of bookings a minute. We have scale. And that scale is often a problem, because as much as we have scale in clients, we also have a huge product. And that product is a fruit of work of many, many developers, many teams, and the standards could be upgraded. We have problems that are caused by Python itself. that doesn't enforce strict coding guidelines. We have a very changing environment. Requests change from day to day. Things move, things fluctuate. We grow, 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 and there are pains with growth. And we have to handle them rather well, or else we will fall behind. Python was a moving line. It let us grow rapidly. It let us adapt to changes. But Python also provides some problems. It has problems with type security. Python is a dynamic language, one of the best. But that is not always a good thing, especially when you work in a huge company, when you have many different teams. Sometimes you need to be stricter with things like that. We had problems with dictionaries. Dictionaries are flexible, but sometimes too flexible. Sometimes when you have a hammer, everything looks like a nail. When you have a dictionary, you don't actually do object-oriented programming, you just throw a dictionary everywhere. And we have problems with Python's approach. It just nudges you forward with its Zen of Python and some standards, but there's often more than one way to do it. And we have to fight that, and we have to make sure that the one way we choose is going to be consistent. We have a lot of challenges like this, but we try to overcome them. Among those, we have the speed of delivery we need to maintain. We have to deploy daily, weekly, every day, usually multiple times a day. Our system that Stanislav has described is very flexible, very secure. The continuous delivery lets us not worry about the things like test builds, etc., about QA going at it for months. Whose job here entails delivering product, releasing every day? Could you raise your hands? There's only like 3 people. Basically, it's very hard. It's a very hard problem that we have to maintain. Otherwise, our competition, our environment is going to crush us. We also have unacceptable downtime. Who of you had their application crash for longer than 2 minutes in the recent month? Anybody? A lot of you. Basically, in every minute we crash, we lose over 10, 20 bookings that bring us money, that keep us going on. And crashing for longer than that, for longer than a couple of minutes, is very noticeable. People have to lose paychecks because of it. We move fast, we have to think about it, we have to make sure we don't fail. And also, there's the motto, there's the key. We try to make travel better. We have to be reliable for our customers. We have to be reliable for the travelers, because if your system fails, somebody may stay stranded on an airport. Somebody may miss their flight because you've told them it's going to be 3 hours later than it's supposed to be. We have to maintain a very high level of quality, and we have to do it while being in a very chaotic environment. It's hard work, but it pays off. We have great tooling. We have the best in continuous integration. We have some amazing static code checks. Generally, our source control going forward is pretty flawless. We try to keep it as optimal as possible. We have a problem of some old legacy code rotting in the background, but we try to do the Boy Scout rule. We try to keep it better. Whatever we find it, we leave it better than it was. We also try to do process, but in some measured levels. We try, as I've said, we try to ask for forgiveness than permission, rather than permission. So we do all kinds of processes that help us be more independent and work more efficiently. That's things like no meeting days, things like being blameless. You have the responsibility to make the product better, and you are going to have all the rights to do it until you prove that you can't. So as long as you do act in good faith, as a developer in Kiwi, there's a lot of things you can do. And we try to keep safety nets. As I've said, when you make mistakes, somebody is going to be stranded at the airport, somebody is going to have problems, and we do a lot of exception control, a lot of error management that lets us know exactly who had problems, why, when, and to have our amazing customer support contact them, work with them, and help them reach their destination. That applies to many things in Kiwi. We're very proud of our customer support. That just shields us developers from things that do happen when you're programming. When you program, things will break. And you always have to have a safety net. These are some of our tools we use. My colleague went into detail with most of them. I'm just going to list them. We use PyLint, Koala, SonarQube, MyPy as static code linters. They check code. Most of these you've heard of, some of them you haven't. They're pretty great tools. I encourage everybody who has a company we're talking about to have at least some of these tools. And yeah, taking a picture is a very good idea. We use a set of tools for logging and incident management, Sentry, PagerDuty, Kibana logs, the whole stack. We also use the Datadog to follow some better trends in our programs, to follow incidents that happen but shouldn't happen often. For example, we even track when our partners use our API incorrectly. Most people just discard it. Somebody messes out. We track it so we can say, hey, you guys, you're not doing it completely right. Let us fix that for you. We try to have reliability as one of our motives. I've went into much more detail about these tools and the processes related in a talk that I've had in PyConf Moscow. And I'll probably have again. You can find it there. So, what do I do? This is all about processing Kiwi. I personally was called, and still am called, the bagman, because I've worked on a refactor of the baggage system, of the systems that compute how much a user can carry to a plane, to any of his planes in the whole itinerary. As we work on something called virtual interlining, where we interline multiple airlines, this work gets difficult. It becomes problematic because a lot of airlines have small hidden text, they have the small print, you don't know what you're doing. I still get lost. This is my full-time work, and I still get lost when I have to travel. Sometimes you just look at it and you don't know. In one paragraph it says you can bring a full luggage, in the other it says it will go somewhere else. Third one says we don't guarantee you anything. Basically, a lot of airlines play stupid so you can buy the most expensive packages. We try to whittle it down to tell you, no nonsense, you can bring one bag, it can be this heavy in these dimensions, that's it. It takes a lot of work, and from the beginnings, from the startup beginnings, when we just counted one number, the whole booking with all its passengers, all its flights, just had one number for bags. And God help you if you needed something more complex than that, because you didn't get it. Now we track it for every flight, for every passenger. We try to have it very, very managed, very, very molecular. It still has problems. We're still growing in that regard, but it's much more reliable. And I'm also in charge of Mambo, which is manage my booking, but spelled fancifully, MMB, so Mambo instead of MMB. It's a system for adding additional stuff after you've paid and registered your booking. Extra bags, extra meals on board, things like that. We try to get as much of those to be a part of your travel experience as we can. And Mambo is going to be in charge of all that. A lot of this, as I mentioned, is precise, but when it can be. Sometimes it can't, sometimes you need to make assumptions and fix them if they're wrong. And it has a visible impact. You can see literally how many customers complain, and if they complain less and buy more, you know you're doing your job right. And it feels very good to have such feedback available to yourself. We work in booking as a department, and we're in charge of the monolith. We recently renamed our booking to monolith and started whittling off microservices every now and then. Basically, our whole infrastructure used to be method-oriented. It used to be something soapish, something where you would do an endpoint and it would do work for you. You didn't think about resources. You didn't think about how those resources interact. You wanted to make a booking, give me a booking. That's easy to start with, but as you grow, as you want to extend, you realize it's not really scalable. You need to go and think about resources, about batch operations, about multiple things that consist of a booking that booking consists of, and that made us move up to more resource and item-oriented approach. Something that also syncs with object-oriented programming. Some people may call it turning Python into Java, but sometimes it's necessary to add touches of that strictness to your code, especially when you have hundreds of people looking and working with it. We try to be REST-ish. We are aware that it's a very strict architectural guideline, and we take it as a guideline. We try to follow most of the standards, and we validate them, but sometimes business takes precedence. We use on our stack Flask integration called Connection that uses OpenAPI, also formerly called Swagger, to validate the schema. This is the way we manage to whittle our big monolith into more and more services. We force everybody to follow this schema, this OpenAPI specification, and if you have it equal on both sides of the network, then you can guarantee that you're going to have the same payload as the service you're requesting. So you can send things more confidentially. You don't have to worry about whether that single item is a number or a string or a double, whatever. You will have a schema there that will be able to validate it, and Connection does that automatically for you. Our work is demanding, and especially when you work with old code, it requires a lot of mapping of the processes. An example would be that recently I worked with some restricted airlines. We had airlines that do not get baggage, that you cannot get bags for. But we figured out that we have a service called Backpack that simulates all these baggage restrictions, that calculates them. And we figured that we can do these two processes, banning of baggage and creating dimensions, at the same place. We moved it all off to them. So we removed a lot of code that was lying there, not really being practical. Seeing that an airline that is restricted just can have 0 items of baggage and your problem is solved. You don't have to have edge cases at 20 different places in your code when your source just removes that possibility. Handling these edge cases, these small branches of your code that build up, is one of the biggest problems in refactoring. Most of the old code becomes so ugly because it builds up edge cases. Everything starts perfect and simple, but you add complexity. And to break that complexity down, you have to map your use cases, you have to figure out why are you doing something, and a lot of problems just disappear. You can remove things that were implemented but are no longer necessary. You can fix things that need fixing. The basics of our whole work were these services that we split off. Most of our work consists of that, of trying to get the monolith into smaller services that will be more reliable and that we can work on and build new verticals with. So some summation here, some takebacks, some things that you can keep are that you need to invalidate those edge cases, as I mentioned. You need to find out what your process is like so you can figure out what to remove, what to simplify, and what services make sense. It's not good to just pull it off whenever you can. The system can usually be forced into a stronger model. You can simplify inputs and outputs, and as you grow, you get to choose some things. You don't have to fulfill every edge case because the complexity will never stop growing then. You have to simplify those things and to be a bit rough. Operations on an API don't work. They just don't scale. You have use cases that are different, and the more use cases there are, the more operations you will have to support. Eventually it becomes ridiculous, and you figure out that all of those can be simulated with just working with objects, with some items, some resources. And taking that approach is pretty obvious. We also realized that we need to use Python better, that we need to validate everything, that we need to add typing, add some MyPy, some static checks, because working with many people is hard when you can write anything, when you hack things apart. And that requires imagination, that requires breaking things, and we try to reduce it. We try to type it to force people to be more strict about their code, to follow these schemata, and work together rather than individually be inspired with their code. We also use modules generously. All these schemata we create, we share amongst all our services. So a Python module that you host internally, hopefully, can be used by all your services, so the code reuse is there. So you don't have to be thinking about, oh my god, I'm doing microservices, I will have to write the same configuration 600 times. No, you don't. Just reuse it multiple times. Enforce it by using your tools, and in the end have a rich, strong microservice architecture. Basically, connect all your hundreds of applications into one that will work together. Thank you for your attention. That's going to be all. Any questions?
Thank you for your talk. How many microservices do you have now?
It's a couple hundred, from 300 to 500. I'm not sure exactly.
Wow, that's huge. And I have a second question.
Sure.
What about typing issues in Python? How do you handle them?
We use MyPy. We enforce typing with MyPy, which is great. I like MyPy because it allows you to selectively type certain parts. Sometimes we really need the Python's dynamicity. We need to be super dynamic. There we just don't use MyPy. We skip that part, we simulate it later, and force everything into types where it makes sense. I think it's a perfect balance because it works on a per function basis. It doesn't work on the whole code base. You enable it where you need it.
Thank you.
No problem.
Thank you for your talk. How do you share Python packages between your microservices, your internal Python packages?
We just set them up with PyPy, as you would set up any pip package, and install them the same way. You can find tutorials online easily.
What about your internal packages that you don't want to share on PyPy?
You can implement it on your own server. You don't have to always share them on the PyPy.
Do you use Warehouse or something else?
What do we use again, Stano?
Sorry?
PyPy iCloud.
Okay, thank you.
No worries.
Thank you for the talk. As I understand, the splitting the legacy monolith to microservices was a part of refactoring. But you know, when you decrease complexity of monolith and brings microservices, especially 200, as you have, you bring another complexity. Imagine if you will rewrite the system from the scratch. Will you still use microservices, or will you build it more monolithic?
If we started from zero, I would definitely make sure that we would follow more strict business logic and allow our core logic to be reused in all of our microservices. So the core logic would stay the same, and it would have a same architectural center, but each implementation detail. Like most of our microservices are services for mobile clients, for other clients, for partners, for different companies that use our API. They're most valid variations on the same basic business logic. And currently, Monolith still has a big problem with that business logic being very intertwined with application logic, because Python lets you do that. Python lets you modify the request that somebody sent you, and you just do. And then you end up doing business logic on a request, on an HTTP request. And that's very dirty. That's very unmaintainable. So most of the modules should be separating that, moving away that implementation details into a separate place until our monolith becomes booking again and becomes clean business code that we can see and move business and code one-to-one.
So it will be more stateless operation services.
Excuse me?
It will be more monolithic services for operation, for business logic, and just a few for resources.
Yes, exactly.
Thank you.
Thank you. I just wonder, how do you manage to gather all information about bags for airplanes manually or some kind of automatically, or?
It really depends. We have multiple different modules that all send information to one center, and that center is a knowledge base for our baggage. Sometimes you need to edit it manually, sometimes our crawlers can find it, and sometimes customers fill it themselves, or airlines give us an API. It all depends on the partners we're integrating.
Great, thank you.
No worries.
So thank you for your talk again.
Thank you for your attention, and if you have any more complex questions, I'll be around after on the beers and possibly the vodka.